Hi everyone, today we are going to talk about a very interesting topic. It's called the structure of an atom, and it's very important to learn about what an atom is, how it looks like, what it consists of, because it's going to persist for a long period of time starting from your 7th or 8th grade, and it's very important to know about how it works and some other concepts. So starting off a bit with a bit of introduction. Atom is the smallest independent unit of matter which can further be divided into different subatomic particles. We will get to know more about it. So first, let's have a look about how an atom looks like. So I want to add a few things first, that John Dalton was the first person to propose about how an atom looks like, or he can be he's also famously known as the father of atomic theory, and this atomic theory was modified over ages, and it stands where we are now today and how the atom looks like. So he has a lot of contribution to the world of atom. So the structure of an atom is quite like our solar system. We know that in our solar system, at the center there is the sun, and there are different orbits around the sun where the planets encircle the sun. So this is how an atom looks like. The center of the atom is called the nucleus, and around the nucleus there are these shells or orbits through which some subatomic particles revolve around it. So what do we have inside the nucleus? What resides inside the nucleus? These are the protons and the neutrons. The protons are positively charged particles, and the neutrons are neutral particles. So I'm just putting a plus sign here and a 0 here to make it easy for you to understand that protons are positively charged and neutrons, they do not have any charge. But do we have any other type of particles? Are there any negatively charged particles, or where do they go? So the negatively charged particles are called the electrons, which revolve around the nucleus in certain fixed paths or orbits, which are also called shells or energy levels. So there are a lot of synonymous words for it. You can name whatever you like. So these electrons, these are negatively charged. They carry a negative charge. So this is how the structure of an atom, a basic atom, looks like. So I'll just add a few more details over here. How does this atom work, and what other concepts we can have from this? Suppose this is an atom. The total number of protons in an atom is always equal to its number of electrons. P here indicates the number of protons and E indicates the number of electrons, of course. That is why the atom is always electrically neutral in nature. Very interesting. Now let me add one more thing. So what other things we can have from this? What do the neutrons do? Like, what is the role of a neutron? The total number of neutrons and protons in an atom are called the nucleons. They are together known as the nucleons. And in an atom, these nucleons indicate what we know as the mass number of the atom. This is very important when you are trying to represent an element. When you are learning the language of chemistry, how do we represent an element? So this mass number has a very important role to play. So there is another one small thing besides mass number. It is called the atomic number. What is it? The atomic number is actually algebraically equal to the number of protons or the number of electrons in an atom. That is the atomic number. And how do we represent an element using mass number and atomic number? It's very simple. Suppose we have an element X. The atomic number is always represented by Z, and it's written at the bottom of it, and the mass number is represented by capital A, and it's written at the top of it. So suppose we take the element hydrogen here. We know that hydrogen has one proton and one electron, and it has no neutron. This is the first isotope of hydrogen. Now what is an isotope and where does this word come from? Let me quickly add a little bit more to this. What is this isotope and how is it coming all of a sudden from nowhere? This is how the structure of hydrogen looks like. This is the atomic number, or which is called the number of protons or number of electrons, and this is the mass number and is denoted by A. Suppose we are slowly increasing the number of neutrons by 1. Here there are no neutrons. It has one proton and one electron. Suppose we are increasing the number of neutrons by 1. We are making it here 2. That is, the P plus N has increased from 1 it has increased to 2. Now suppose we are increasing it one more. We are making it 3. So the number of neutron has increased one more. So this is what generates the characteristic of an isotope. And what is an isotope? An isotope of an element is this, like it's the same element having the same atomic number but the different mass number. And this different mass number occurs because the same element carries different number of neutrons. This is what the characteristic of an isotope is, and that is why different elements in our periodic table have isotopes, like hydrogen, like oxygen, like carbon, and there are many other elements. So to wrap up, an atom is the smallest, most independent part of matter, which can be further divided into protons, neutrons and electrons. The total number of protons and neutrons is known as the atomic number, and the number of electrons and the number of protons is always same in an atom. That's why the atom is always electrically neutral. It is known as the atomic number. So far, whatever you have learned from this lesson, these are very basic concepts of atom, and it will help you understand further advanced problems of atom. So I hope you liked my lecture. Thank you so much.